so let's start with the classic, with a definition. What is natural language processing? It's basically a subfield of artificial intelligence, like all the other stuff I mentioned. We will see that in more detail shortly. And it focuses on enabling computers to understand, interpret, and generate human language. So it combines linguistic, computer science, and AI. And the goal is to bridge the gap between human communication and machine understanding. All right. So to not to mix things up, let's quickly see how NLP fits into the other AI definitions we just heard. So first of all, we have AI, which is a broad field that seeks to simulate human intelligence. We then have machine learning, which I just mentioned, which is a subset of AI that focuses on learning patterns from data, like I just mentioned with fraud detection, for example. Then we have deep learning. Deep learning is a subset of machine learning, and it focuses on neural network architectures with multiple layers. That's why it's called deep layer, because it has multiple layers. And then we have NLP, which is both a subset of machine learning, because it deals with tasks like classification, sentiment analysis, NER, which stands for name entity recognition, and it often uses supervised or unsupervised machine learning algorithms, like, for example, logistic regression, support vector machine, decision trees. However, it's also a subset of deep learning because it uses deep learning architectures, like neural networks, especially those based on transformers and, of course, powered state-of-the-art NLP. Systems like GPT stands for Generative Pre-trained Transformer, like I mentioned it before, GPT-4o, which is the basis of ChatGPT, for example. Don't worry too much. I realized I just mentioned two concepts that are probably not already familiar with you. So the first one I said was transformers. So transformers, I don't know if you heard that already, is a special deep learning model that allows model to process text way more efficiently than older architectures. And when I talk about older architectures, I mean, for example, recurrent neural networks with short RNNs, or long-term short-term memory LSTMs. These were the old architectures, which were fine, but transformers are way more efficient and were a kind of breakthrough in the last years. And the second one is GPT. Again, it stands for Generative Pre-trained Transformer. And it's a specific type of transformer model, a specific type that is specifically designed to generate human-like text based on pre-training on very, very large data sets. That's why, for example, it is so expensive to train models like GPT-4o, which costs a lot of resources. Yeah, all the OpenAI models are, for example, GPTs. That's hence where the name comes from. GPT-4o is probably the most popular one right now. This one has also, just to give you more background information, this one also has some enhancement, which is why is it called O. The O stands for Omni, and Omni indicates that GPT-4o is also optimized not only for text, but for vision and audio as well. That's why you are capable, for example, when you type text into ChatGPT, you can also upload pictures or use your voice to run prompts. This is only capable with Omni models, okay? Okay, so that's just a little bit of background for the words I was just using. Let's now take a look at some real life examples of NLP, just so, because I've previously said it's already part of our everyday life. So let's see what I mean by that. So first of all, of course, we have since a long time personal assistants, Siri, Alexa, Google Assistants. We now have, like, I think it's now 3 years, or we are like, I often call it like, it's now 3 years after ChatGPT, if you think of a era. So we have, of course, chatbots. We have virtual customer supports like ChatGPT, but also Gemini or Zendesk has been around for quite some time. We have perfect machine translation, Google Translate, but also the company BeepL is very, very good at machine translation. We have sentiment analysis, which there are lots of social media tools or monitoring tools out there to get the sentiment, for example, from social media. And we have email filters a long time around, spam detection filters like the classic Gmail spam filter that is very, very good nowadays. So it's very rare that you receive spam in your normal folder, which you might have realized. We have text summarization. Just look at your Microsoft Teams. I think in this version it's already included, the summarize. We will see. I will get a transcript, and if you have like the Pro version or the 360 version, you should have the summarizer as well integrated. So that uses NLP. Zoom has a summarizer as well. So that's areas where NLP has taken over. We have, of course, search engines. If you look at the results nowadays of all the top results from Google, they are already summarized and prioritized just from the NLP tool that lies behind that. We have speech to text, short STT, like a tool that is very popular is Deepgram. So speech to text basically means exactly what it says, like converting speech to text, and like the Teams is doing right now, probably to transcribe our lecture. And we have the other way around, which is TTS, text to speech. And one popular model for that is OpenAI's TTS model, which is surprisingly free. We will use that as well, because I think it's very good compared to other models as well. And as I said, it's free. So that's a broad overview of NLP and in which areas and it has already like kind of taken over. So let's now check out why should we even care? Why? Oh, to put it in another way, why has NLP become so important suddenly in the previous time? Like, let's instead ask the question, imagine for a second computers couldn't understand human language. How, for example, something like Siri or Google Translate or automated emails function or emails would function. Like without NLP, it wouldn't even be possible to have seamless interactions between human and computers. And I'll demonstrate to you how much NLP is already integrated in our life by just showing you now a couple of examples how NLP has already transformed not only areas but different industries already. Like we have healthcare, of course. Healthcare generates a vast amount of unstructured data. By unstructured data, I mean, for example, patient notes, a lot of research articles, medical records, and NLP enables healthcare providers to, first of all, unlock insights and then also to improve efficiency for that, like identifying key symptoms, diagnosis, and treatment from patient records. And tools like what's his name? IBM Watson Health assists in predictive analytics and personalized care. And then we have in research, summarization helps review new papers because there are so many new papers coming out. And it also helps analyze and synthesize findings from clinical trials. Something we also see more and more are definitely speech-to-text transcription of doctor-patient interactions. And in finance, where I'm coming from, we often deal with really large data sets, news, reports, social media. So NLP just enables us to organize that data and also to sentiment trends and risk analysis and identifying patterns. Of course, like in my field, the AML and fraud detection. So another example would be NLP helps tracking sentiments from news articles or from social media to predict market trends or to identify, as I said, potential risk in financial reports or also in regulatory filings. And it also identifies, as I said, patterns in transactions or communications that could indicate fraud. Another interesting area, which I have also mentioned a couple of times, is customer support, because here millions of customer queries require fast, accurate, and personalized responses. So NLP tools like the previously mentioned Zendesk really transform customer support with different chatbots and automations like FAQs, ticket routing, or escalation. He also in NLP also has enabled support in multiple languages using translation and intent recognition. Good. Now that we have seen or understand the NLP's impact, let's now take a look at some of the tools and applications I have just mentioned, the components of NLP, right? So understanding the core components of natural language processing is essential for tackling language-based problems, because these components form the building blocks of most NLP workflows, if not all. And the first component we want to take a look at is called tokenization. Tokenization is the process of breaking text into smaller units, and these units are called tokens. That's when I previously mentioned about how much it costs to use an API. We are not talking about words, but we're talking about tokens, which is most of the time similar but not accurately, because it's not words, it's smaller units of the text. And this can be words, this can be sentences, or it even can be subwords. So it basically converts unstructured text into a structured format that models can again process, So that is called, well, first of all, there's word tokenization. I'll give you an example of this. Like, let's say we have the sentence NLP is fun, then the tokens would be NLP is fun and the exclamation mark. And for example, sentence tokenization. Let's see an example for that. We have NLP is fun, let's learn. So then we have two sentences. The first one is NLP is fun. The second one is let's learn. So that's different from word tokenization. And of course, you don't have to do this manually. There are Python libraries which fortunately help us to do this. And we, of course, will see them later in practical examples. And two of them that help us to do that are called NLTK, or another example is called Spacey. The second component we want to take a look at is called lemmatization, which basically reduces words to their base or root form. That's where lemma stands for. And this ensures that the resulting word has meaning, and it also helps in normalizing text by grouping together inflected forms of the same word. An example would be running. From running, we go to run, which is the lemma of this word, or from better, we would go to good. Okay, that's our two basic examples. And again, there are, of course, Python libraries that help us to do this. And this is, again, NLTK, or specifically the package we want to use is called WordNet Lemmatizer. Next thing is, I previously mentioned this, to also to get like unstructured data into structured data is called named entity recognition. Short is NER. And NER identifies and classifies entities in text into predefined categories. We don't have to define these categories. These are predefined, and these are like names, location, dates, organizations, for example, and it helps extracting meaningful information from unstructured text. Let me give you an example. Tobias Lemle, that's me, was born in Stuttgart in 1980. So if I run named entity recognition, I hopefully get Tobias Lemle as a person and Stuttgart as the location and 1980 as the date without doing anything. That should work perfectly fine. And the Python library that helps us to do that, for example, could be Hugging Face Transformers, which is a very popular open source model to do that out of the box, of course. And then, what else? We have stop word removals. I guess you know what stop words are, the things you probably shouldn't do in like presentations. Some stop words are common words, for example, like and, is, that do not add significantly meaning to the text, which we all experience when someone is doing this a lot, I guess. We want to get rid of them, and we want to get rid of them to reduce noise in the data to improve our model performance. Example, again, the weather is nice today would be shortened to weather nice today. That's all we need of of information. Again, a Python library is there to help us, and it's again from NLTK, and this one is called, it's called StopWorks, which we'll also see in action in a couple minutes. And you don't have to memorize anything of that. Just there are libraries to help you do this, and if you have written this once in your code, this is totally fine if you use this as a kind of boilerplate. At least that's what I do, and just reuse it every time. Yeah, so you don't have to memorize anything of that. Also not for a test. We will never do like memorization test or something like that. Yeah, just to let you know, these are some libraries that really help you doing this out of the box without doing anything. So the workflow, or how all of these components in the end work together, is something like this. Just an example workflow that you could run through when doing something like that. We should start with the raw text, unstructured raw text, a lot of unstructured raw text, which we will then tokenize. Okay. Then we remove the stop words included in it. We reduce the words to their base, which is lemmatization. And for example, we could use something like NER to identify information. And only then, after doing all of this, only then we start to train our model. Okay, not before, not with the raw text. This is the steps we have to do before that's called pre-processing, and that will take a lot of time. This will take like 80 to 90% of your time before you start training your model, and it often never happens because you just can't get good information out of the raw text. Okay, just to give you, I don't want to disencourage you or something like that, but just to give you a heads up, this will take a lot of time. Good. All right, let's move on and check out some interactive examples. So here are some demonstrations of interactive examples or real life world examples. So just so that we can see real world NLP in action. The most prominent application, of course, right now is chatbots. We all know that. Everybody on the planet knows ChatGPT or any similar model. So yeah, let's switch from the slides to the browser and take a look at a basic, let's call it Q&A assistant with an AI chatbot I want to show you. Not the classic ChatGPT, but something I just built for the sake of this course. So starting my script, and now this is the basic chatbot that I built. It runs on or it uses different APIs. I'm saying different because I integrated different models. For example, you can use GPT-4o to answer your questions, but also the new Chinese model DeepSeek, or two models from Meta, which are called Llama 3, 70B or 70B versatile. So the user can select one of these, and then you can just ask questions about yeah, let's for example about the University of Bozen, and then you get a result. And so that's not a lot of code. That's like 15 lines of code. I can show you this later, but just 15 lines of code and call an API just to build something like this. That's not difficult at all. And interesting is, for example, you could switch the models, and let's say it is NLP. So you see, I used OpenAI's GPT-4o for my first question. For my second question, I use another model, but the model realizes what I ask in the first question. Okay, and that's a reasoning model. So you always get the thought process as well. Or I printed out the thought process of the model as well, because it's so interesting how an LLM model is thinking. Okay. So you see, it takes the first question, realizes, okay, I might be enrolled in Bozen, and I also want to know about NLP. So I find this fascinating. Okay, and also you can like compare the results of different models. Okay, we can I can start all over again. But it's not really starting all over again because I'm in the same session. But okay, I'm starting with a question about university, um, and then I could switch the models, and the models still have the previous answers in the cache, but use it to answer my question. And if you go back, you could. The interesting part of the DeepSeek model is that it also prints out his thought process. If you have additional questions, which is pretty interesting. And if you want to see, and this is not real. Um, okay, so this is the front end. So there's nothing to learn here. It's just I built a front end using Chainlet, which is based on React. But here I'm just you have this. These are the four plates beneath the model where I can put in like predefined questions. And here this is the drop down menu for the different models. But the code is here, and it's basically a very well-defined plant. Um, and here I'm using the previous conversation, and here I tell the model where it gets which model it should use to respond to the user. Okay, so I've been having GPT, have DeepSeek, Llama, and you could also incorporate other models. And that's like basically it. You put that stuff together. It's one function. It's 20 lines of code, and that's it. So it's might be looking not very simple, but it's simple, and it's not a lot of code, as you see. And we will I will teach you how to do this on your own. And also, like, this is just a basic chatbot, not a rack system. Like, you could also I will show you also how you could improve on that version to use like other materials, or we could also try to use a model like Sonar Pro from Perplexity AI, which is a web search model, to incorporate new data, because as you know, these models are trained until a certain day, so they don't have like current data, but there are models out there that are able to search, so you could incorporate that as well. But that's your basic code with what you start, and then you can improve on that. All right. Okay. Yeah. So that's a very common example, or the most prominent example of NLP in action, Q&A chatbots. Let's take a look at another popular application, which is of course uh, sentiment analysis. And so sentiment analysis is another popular example, sentiment analysis tools. And with sentiment analysis, we try to analyze the sentiment, of course, of a conversation, and we can use this with specialized models that do sentiment analysis, but also those big these big GPT models, because they are so big, they can do this out of the box as well. So let's see another example for that. There's maybe okay. Again, most of the code you see, like 60-70%, is just the front end, which you could like copy paste from anywhere. That's the whole sentiment analysis tool, which also can has a little bit more functionality, which you will see when I run this. So let's run this. Of course. Okay. We're doing another purge. Okay, I'm have to switch the port. Something is blocking my port, so I'm running this locally. That's why I have to use a port. Again, if you have questions regarding this, please feel free to ask. But it's just for demonstration purposes. Okay, so we have here. It's not a. It's made with fast APIs and not as beautiful as the React front end, but it does the job. It's a basic chat again, so I can chat with the chatbot, but it also counts the messages, and it classifies the current sentiment of the current conversation, so ongoing. As far as of now, I just said hello, and chatbot answered, so it's neutral, okay, because it's just a simple. And it will also give an explanation why the chatbot think it's neutral. So let's put some emotions into it. Let's say I am really liking this new NLP course, which you all probably, hopefully, all agree. And you see, okay, the sentiment now is positive because here's the explanation: user expresses enthusiasm and enjoyment. So let's try something different. All the previous courses really underwhelming! Exclamation mark, exclamation mark, exclamation mark. Okay, so so you see, it is not only capable of identifying a single sentiment, but analyzes the whole conversation, and also is able to qualify this as mixed right now because I switched from a positive to a negative emotion. But it's not negative in total. It's mixed right now because I'm having a lot of different emotions right now. Okay? And it also gives you the explanation which words are responsible for the current sentiment analysis. Okay. Also, very simple stuff. I did this out of the box with GPT-4o. No pre-training, no prompt engineering, nothing. This is working out of the box perfectly. And this works, of course, with open source models as well, which don't cost me money. But if you do sentiment analysis of a chat, it doesn't cost a lot of money because, as you now know, this is not a lot of tokens. Okay, good. So that's another. So we had a chatbot, we had a sentiment analysis. Let's move on to speech to text. So what is it has two functions. First, you can record your voice or something like that, and then it will transcribe in real time. And if you'd like to, let's say, this is like for you plotting out ideas, and you want to rewrite them in more professional way, you can use it for this, like record and then rewrite it in one go. So let's see if that works, because I don't know if it's still recording. Hello, is this still recording? It's just a test. Stop. Okay, it works. So it's very fast, as you see. It's not near time, it's really real time. I know I could use this to rewrite it as well. But yeah, there's nothing. Okay, it uses just a little bit more grammatically correct language. But you can see what I'm going at. Like, this could be a use case for to dictating stuff and then rewrite it in a more professional way in one go in real time with no, like, it costs cents. Okay, it really costs cents, really, really fast. For PTS, that's here, which is the name. Let's try this. I'm gonna zoom in a little bit. I'm gonna a little bit explain what is happening here. So this is the key I was talking before, because I'm using OpenAI's TTS to do that. It converts text to speech for free, but you need an API key. So that's what's happening here. Then I have just the input box for the user to put in his text he wants to convert. And then we can select different voices. Why is that? Your OpenAI PTS. So here's the documentation of OpenAI, and we can see here they offer a lot of different voices, and you can pre-check how they sound and then select the voice you like the most. And that's why I selected all these names and give the user the ability to select one of those. And yeah, let's see if it works. So, as you see, this is not even 20 lines of code to do that. It led for a real-time text-to-speech model, and you can build an app around this as well in maybe another 10 lines of code. Or active examples for your live use cases. So where we are now, let's recap the theory, the NLP theory we have learned so far until now. So we have seen what are the key concepts. We know what NLP is capable of. It enables machines to understand, interpret, and generate human language. We also saw a couple of applications, like we saw chatbots, we saw sentiment analysis, we saw speech to text, we saw text with speech, and we will see later what information retrieval is in the case of ROAC model. We also learned about the impact NLP has on our daily lives already, from industries like healthcare, like finance, customer support, where language-based tasks get more and more automated, as we see. Let's move on to the tools, the tools that make NLP tasks easier. So let's imagine a large data set of, let's say, customer reviews, which basically involve a lot of text. Using NLP libraries, we first, as we have seen, we have to clean the data. We want to extract insights from those reviews, and we even want to predict customer sentiment, all without building a model from scratch. So not in the next session. In this session, we can do this right now. We'll explore these libraries I've already mentioned in a couple previous slides, and we use them to perform text processing and also work with a pre-trained model. So what is the objective here? What are we going to do? Well, the goal is we want to clean and pre-process the data set for text analysis by performing tokenization, by performing stop word removal, lemmatization, and then at the end we want to visualize the whole thing by, for example, a word frequency distribution with a word cloud, probably. So first step is load the raw data, which we saw in this workflow. We then tokenize. That means we tokenize the reviews and we examine the structure. And then we clean the tokenized words by removing common words, the stop words, and also reducing the words to their base or lemmatization. And then we visualize it by using the most frequent used words in the processed text. We do this with a library called matplotlib and a function called wordCloud. So the raw data I want to load is a review data set from an airline. I think it's American Airlines. It's a CSV file, and the file is called airline dataset. So let's start coding. It's fine like that. Yeah, it's fine. Okay. Yeah. Okay. First, we start off by importing libraries, because I need to import, or I want to import this data into a pandas data frame, which you probably know. I'm going to have to import pandas. So the way I do it, at least you don't have to do it is this way, but the way I do it, I collect all my imports at the top of the notebook and add to them as we go. So let's load the data and put in a data frame called df. So here you have to put in the path where you stored the CSV file. I put the data into a folder called data, so adjust accordingly. So let's take a first look at the data. All right, so 20 columns and 23,000 rows, and we are interested probably in the review because we want to do a sentiment analysis with this review column to see, is the sentiment of those American Airlines reviews more positive or more negative, or what is the current state or the towards this airline. All right, so we have imported that, and then next step would be we want to tokenize the sentence, and also we want to remove the stop words. We saw why we do that, and I also mentioned a couple of libraries that help us to do that. I also put them down here just with a little bit of explanation so that you can reread this. So let's import these libraries from NLTK that help us with tokenize the sentences and also that help us to remove the stop words. So the first one, you do this with nltk.download and then just mentioning what you want to download. First one is called don't. Then we have stop words will be the next. During stop word, we have WordNet, which is just a large database for English words. And we don't want to reduce it to English. That's why we use OMV, which provides translations to a lot of other languages. So then we have to define stop words and lematizer to use them later. Our bug word, you have to set it by calling .words. And it's English, the values are in English. And we also initialize the lematizer and save it in lematizer by calling WordNet lematizer. And then we write a function to pre-process our text using the stop words and the lematizer. We just initialized, let's call this function pre-process text. It receives the text. In that case, the text is the review. All right. And let's do words equals word knife. We probably don't have to do this. I'm not really sure about WordNet, but just in case, let's do lowercase, just to make sure all the reviews are lowercase. And then we can use the lematizer on each single word. And now we write a for loop. And we want to exclude stop words. So word not in, how's it called? Stop words. And that's it. And then we should be finished and we can return our cleaned text now. All right. But that's our function that should work. Just to make sure, let's quickly run it. NLT is not defined. Why? Because I didn't import it. So I have to import it as well. Import NLT. Okay. And now I can try to run it again. Okay. Packages get downloaded. Stop words is also not defined, so I have to import that as well. So that's import NLPK. I think it's tokenize. Import. No. Corpus. Import stop words. No, that's from. Sorry. So I don't import everything. We just need the stop words from NLTK. We had lematizer. Yeah, if you don't use that often, it's a little bit tedious the first time because you have to import everything from scratch. But yeah, we can, as I said before, you can use this as a boilerplate for the next NLP tasks we do, because then you know which NLTK libraries you need. So what was I missing? Word lematizer, I think. Import add lematizer. Run it. See it again. All right. So all packages have been downloaded now. So we can use now our function preprocessed text on our data frame on, what was the name of the column again? The column is called review. Okay. So let's save it. Let's save it in a new column. Let's call this new column processed text. You can call it however you want, but I just want to save it in a new column. So review is our column we want to preprocess, and we do this by applying our just build our function that we have built preprocessed text. All right. Let's take a look afterwards. Root tokenized is not defined. Root tokenized isn't defined. Oh, another thing is missing here. Okay. Depth from NLTK. Open rights. Import word tokenized. All right. Once again. No. Lam. Ah. This could probably take a little bit of time. This could probably take it. No, it's finished. Because I was just thinking, okay, 25,000 is not really, really small, but it's okay. Okay, so that's the output. That is our review column after we pre-processed. So after we got rid of the stop words and after we we lemmatized the text. So we can work with that right now. Great. Good. Let's say it quickly. Nobody needs time. Okay. And let's move on. So what we want to do is we want to visualize now. We want to visualize, what was that? We want to visualize which words occur the most. Just for example, which words occur the most in these reviews. Like if you could maybe derivate some patterns, or like if a lot of negative words, or if a negative word occurs the most, that wouldn't be a good sign, right? If a lot of positive words occur the most, that would be a good sign. So just to get a sense of these reviews, we start with a visualization of the most occurring words. We do that by we first flatten the list, meaning we get one list, one big list with all words. That for them we flatten it down to a list. So let's start with that. Let's call them all words. All. And we're gonna use, what was the name of the calling process? Text. All right. And then that. Okay. Now we have all words 11, and now we count them. Well, we do that by using counter with our now flattened list. Let's quickly check if that works. Yeah, I haven't imported yet, right? To use the counter function, we have to import it. I'm pretty sure it's in here. All right. Well, why? Heck, I could. Yeah. Okay. But yeah, this is a large data set. Let's say we only want to get the most common words. Then let's do, how many we want to do. Let's say 20. Let's say 20. Like, we want to get the 20 most common words. And I get back the words. I want to get back the number of occurrences. We do that using zip. And now we can plot this. Let's make it a little bit bigger. Are you familiar with matplotlib? Now please let me know. I'm using matplotlib a lot. And yeah, most of the time you start by defining how big you want your graph to be. And as I'm using the 20 most common words, I'm making it more rectangle so that I can get more bars in it. It will be clearer when I'm doing it. It's the width is double the height, so that 20 bars fit on it, because we get 20 bars because I want to get the 20 most occurring words. And we're gonna do a bar chart. That's why I call bar tplt bar. And we want to get the words and also how often they occur by count. Okay. So on the y-axis we have the occurrences, and on the x-axis we have the word. And yeah, I don't know how long these words are, so let's rotate them a little bit. By rotating, they better fit on the x-axis. Let's rotate them by 45 degrees. And that's it. Applied L and C. That looks good. I would say American Allies is fine. If the most occurring word with nearly 50,000 occurrences is flight, and then we have about 18,000 airline and time. Yeah, no, there's even the few positives. We have good, we have food. I mean, if if there's not one negative word under the 20 most occurring words in 25,000 reviews, that's a pretty good sign, I would say. Let's just for for the fun of it, let's do a word cloud as well. It looks a little bit more fancy. If you know the results are okay, then you can produce a little bit more fancy visualization. So let's just do a word cloud also. Word cloud. Of course, we need to import that. This doesn't work out of the box. Word cloud. So let's choose dimensions. We do double the width again. Do we need a background color? Well, probably not. So let's do white. And then just generate over all recalled all words. Yeah, let's call it all words. And then we're done. So we show our just created word cloud. We use interpolation by linear. It's just for layout purposes. We don't need an axis. We can skip this as well. And then show it. Yeah, good. Yeah. So we have a little bit more fancy graphic just to present it maybe to your management that everything is fine. So we see the good positive words in green or blue neutral. Okay,